Hello everyone, my name is Ravi Bhardwaj. I'm part of the Confluent Global Technical Support team, and today I'll be speaking on transitioning to KRaft in Apache Kafka, avoiding common mistakes. First of all, thank you everyone for joining this call, joining this session. I'm really delightful and grateful for this opportunity to speak on this platform. Now, regarding the session, if you think about it, Apache Kafka has been open source for more than 13 years now, and over these 13 years, there have been so many significant changes and improvements done to the project. But in my opinion, no other improvement or the transition is more significant than the transition to KRaft from Zookeeper. This not only removes the dependency of Apache Kafka project from Zookeeper, but it also provides better scalability, high performance, and sets up Apache Kafka for future developments. Now, as you might have just heard in the keynote, Apache Kafka 4.0 has recently released. Now, that is the first version which has been released without Zookeeper. So, if you're a Kafka user which already it's using Zookeeper, you have to at some point migrate to KRaft before you can migrate to Apache Kafka 4.0 or 4.x. Now, although Apache Kafka with KRaft provides lot more benefits and significant performance, the migration, the transition itself is not without its challenges. As part of as per the documentation and as we have seen in Confluent Cloud as well, like Confluent has migrated like tens of thousands of Zookeeper-based Kafka clusters to KRaft without any downtime. So the transition should be zero downtime. But as part of global technical support, we have seen a lot of customers, they follow the documentation, but then still run into some issues because they are not aware of the best practices, or there's a pattern of they running into some common mistakes. So I thought of collating all those issues that we have seen in our team and thought of presenting to you guys, hoping it will be useful for the community, everyone. So let's get right into the agenda. So first I'll be talking about why KRaft, like the benefits of KRaft. Then we look at the migration steps. Then we look at the common mistakes. But then the reason why I wanted to go through the migration steps is when I'll be talking about the common mistakes, you can see why users can do those mistakes when they do the transition. And at the end, we'll look at the best practices. So first, why KRaft? So this is a pic from KIF 500, which introduced the migration from Zookeeper to KRaft. On the left-hand side, you can see traditional Kafka cluster, wherein you had few set of brokers that were acting as a data plane. You had one broker which is acting as both data plane as well as a controller, and its responsibility was to store and fetch metadata from Zookeeper. Zookeeper acts as a consensus service to store Kafka's metadata. Now, as Kafka scales, Zookeeper becomes a bottleneck. So as part of this KIF 500, they initiated the plan to move away from Zookeeper. And on right-hand side is what you see how the KRaft architecture, KRaft-based Kafka cluster would look like. So you'll have again few set of data plane brokers, which core responsibility will be storing data. But they also introduced a special kind of brokers called controllers, and it's a KRaft protocol-based consensus service, which is built native to Kafka. Now, it stores the metadata within Kafka. It's not writing like to a third-party service called Zookeeper. It stores within the Kafka topic, and since the Kafka topic is replicated, all the controllers, part of the control plane, they can asynchronously read the metadata, and that provides better scalability and performance. So why KRaft is better? As we see, it provides better scalability. One of the things, if you have been using Zookeeper-based Kafka cluster, no matter how big Kafka cluster was or how many brokers you had, the recommended number of partitions was 200,000. But with Kraft-based cluster, you can have millions of partitions. There's no such limit. You can, as cluster gets bigger, you may, at some point, like it's not like you can have unlimited partitions, but it's much better than what Zookeeper used to have. Then better performance, because Kraft is native to Kafka, the implementation is very tightly coupled and it better, provides better performance. One of the test results that we have or documented in the documentation is with Kraft-based cluster, the shutdown time for 2 million partitions-based cluster, shutdown and recovery time is 10 times faster compared to the Zookeeper-based cluster. So that's significant. Then easy administration. Anyone who has maintained Zookeeper cluster, they would know about the split brain issues or quorum ensemble related issues. So it's a nightmare troubleshooting Zookeeper. And then when Kraft is native to Kafka, so you're just administering one product and not two. And the last one is no dependency on Apache Kafka, another Apache project. So because Kraft is native to Kafka project, if they want to prioritize any improvements or bug fix or any feature for metadata management, they can do that. They can prioritize it because it's again part of the same project. Now let's look at the migration steps. So before I look into the migration step, one thing I want to make it straight is there is a lot of customers who have done this migration. The migration is complex, but if done correctly, it is expected to be done without any downtime. And in this talk, I wish I can provide more information on how to avoid the common mistakes that everyone does. So we look at the phases now. The what I have here is I've tried to mimic what Confluent documentation has. Like the migration is split into 5 different phases. So first phase is more of the readiness and preparation phase, where we recommend users to go through the documentation, the migration, learn more about Kraft, and see what are the limitations and known issues in Kraft and which are applicable to them. Then making sure the cluster is in a healthy state. So we recommend not to initiate the migration unless there are no under-replicate partitions or no offline partitions. If there are, please fix those before you initiate the migration. Then upgrading to latest CP 7.9 or Apache Kafka 3.9. So these are the versions that support migration from Zookeeper to Kraft. The migration is supported from 7.7 or 3.7, but then there are a lot of bug fixes and feature requests, feature improvements that are made into 3.9. So we recommend upgrading to the latest version. Latest 3.x version. So now latest is 4. So yeah, phase 2, you'll be adding the controller nodes. So these are the nodes that will be replacing Zookeeper cluster. Now the controller nodes, we are adding new set of brokers. Kraft supports 2 modes: combined mode and dedicated mode. In combined mode, the controllers can be co-located within the data plane, but that's not recommended or even supported for Kraft migration. And Confluent doesn't support combined mode at all, at least as of this point. That may change in future. So in phase 2, you're bringing up the controller brokers. You're setting controller specific configs. You're enabling migration. So migration is for specific to Kraft, Zookeeper to Kraft migration. And then you need to format the data directory on the Zookeeper on the controller nodes using the cluster ID that you get from the Zookeeper cluster. Then you do that, and then you start the controller nodes. So at the end of this phase, the controller will will connect to Zookeeper and will fetch the metadata. In phase 3, we move on to the data plane brokers. We set the interbroker protocol to 3.9. And I've used 3.9 because I'm recommending upgrading to Apache Kafka 3.9. If you go with the transition, the migration from 3.7, so you can set this to 3.7 as well. Then we'll set migration on the data plane brokers. point the brokers to controller, and then we'll restart the brokers. Now, when you do that, the migration of Kafka cluster will kick in, and on the active controller broker, you'll see, when the migration is completed, you'll see a log saying the migration is completed. Now, at this stage, still Kafka data plane is connected to Zookeeper, and it's also connected to controller. In the next phase, we'll remove the dependency of Zookeeper from the data plane first. So we'll remove the Zookeeper specific configs, set few KRaft specific configs on the data plane brokers. Then we'll disable migration, and then we'll restart the brokers. Now, when this is done, the Kafka data plane is only connected to controller. It has lost its connectivity to Zookeeper, but the control plane brokers are still connected to Zookeeper. And it's running in dual write mode, wherein it writes, the controller still writes metadata to Zookeeper, and that is why this is the last chance to roll back if you really have to. So if you're facing any issues, if you try to troubleshoot but things are not improving, this is the phase where you can roll back. If you move on to next phase, the rollback is not possible. So in stage 5, we ensure if cluster is healthy after the migration, if clients are working properly, we hear from all the application teams that there are no issues. Once everything looks fine on the controller nodes, we can remove the Zookeeper specific configs, and then we can disable migration and then restart the brokers. So if you have made this far without running into any issues, well done and congratulations. And your Kafka cluster will look like what we have the image here. So this image mimics what we saw in the KIF 500 image, wherein you have few set of controller brokers, and one of them will be acting as a active controller, and the data plane brokers will be connected to the active controller broker. Now let's look at the common mistakes. So not upgrading to latest CP7.x or 3.x. So as I said, the migration is supported in Apache Kafka 3.7. It's also supported in 3.6.1, but it is always recommended to upgrade on the latest version, because when you start upgrading, and if you run into any bug which is already fixed in the latest version, it's better to use the latest version from the start. Next is not reviewing limitations. So there are several limitations that are documented for KRaft. One of which is KRaft modes, which I also talked about earlier, that for migration, combined mode is not it's not supported. You only have to go for dedicated mode, and we have seen users trying to go for combined mode and running into issues. Then the next thing is SASL scram for controllers. So if your Zookeeper authentication was based on SASL scram, and you want to have the same thing with KRaft-based controller, that is not supported. JBot works with KRaft, but it's still in early preview, so it's not recommended for production use cases. And then there are others, so we recommend going to the limitations. Then not testing migration and clients in lower environments. So I would try to split this into two. Not testing migration enough in lower environments, and then also making sure that clients are also tested thoroughly in a lower environments. So even though your Kafka cluster after migration looks fine, you make sure your clients are able to connect to it and are able to produce or consume or do whatever operations that they were doing. Then the next point is continuation of the last point, that not preparing clients for Zookeeper removal. So if you have any Zookeeper, if you have a Kafka client running in the wild, which still points Kafka to using Zookeeper, you should be upgrading the client libraries and pointing to Kafka using Bootstrap server instead. Then finalizing migration too early. So after phase 4, we usually recommend customers to wait for a week or so. Let the brokers see the high spikes, low spikes, and you get chance to hear from all your applications team to see if everything went smooth after the migration. So wait for a week or so, and only then move on to phase 5, because that is the last. Phase 4 is the last chance where you can roll back to Zookeeper. Not ensuring all controllers broker-specific configs are set on controllers. So that is on controllers, controller brokers, which are a special type of brokers. There are some controller-specific configurations, but there are also some broker-specific configurations that needs to go in on the controller side. Skipping those configs will cause issues, and we have seen users running into those. Not ensuring new controllers can reach Zookeeper. This looks obvious, but we have seen users when they spin up the new controller brokers, they don't have connectivity to Zookeeper, so that also causes issues. Then misconfiguration or broker rules. So any misconfiguration, or even if you're setting the configuration correctly, but you miss restarting the brokers, those configs won't take effect, and then that can also have issues. Using different versions for brokers and controller nodes. So we have seen users, when they're using old Kafka brokers for data plane, and they only install the newer version controllers, thinking that will work, but that's not supported. You need to have broker and controller. Even for Zookeeper, it needs to be on a bare minimum version to support KRaft migration. Then next, setting higher controller quorum timeouts. So if you had a distributed Zookeeper cluster with distributed in multiple data centers, so you might have already set higher timeouts on the Zookeeper side. If you're mimicking the same architecture on controllers, you have to set higher quorum timeouts. Otherwise, you'll start seeing quorum disconnections and timeout. Last but not least, if you're using CFK or CP Ansible based migration, the migration would be much smoother and easier. But then those frameworks that have their own limitations and known issues. So better read those documentations as well before you start the migration. So we'll quickly look at the best practices. So the first is don't make the common mistakes that I mentioned in the last slide. So all of these, try to avoid that as much as possible. Then monitor logs and Zookeeper migration state in JMX. So in phase 3, when the Kafka data plane is migrating to KRaft, on the active controllers, we can see the logs which says migration is completed. We can also check the migration state using JMX. So, otherwise there is no easier way to tell whether the migration is completed or has failed. Then URPs are expected during migration. When the brokers are restarted, we expect the cluster to have under-replicated partitions, but that's fine. Just wait it out, let the brokers recover. And only when the brokers have recovered, there are no under-replicated partitions, move on to the next step. Then have a DR environment if possible. So you can use cluster linking or replicator and spin up a new data. Like if you're not already having a DR, try having that. Move your workloads to the DR cluster, and then you can initiate the migration on the earlier active Kafka cluster. And then last but not least, again, it's always have a plan B. No matter how thoroughly you have tested the migration in lower environments, make sure you have you have tested the rollback as well in lower environments, and have the migration plan and the rollback plan also ready when you do it on the production environment. All right, so this was it from me. I don't know if we have time for questions. All right, but I'm happy to take questions outside.